So I guess just to summarize what we deal with over the course of a season, we try to separate it into four types of flooding events. And these are, they're ranked here in terms of their frequency. So number one is very common and number four is rare. But they all have different impacts. And obviously the impacts range, that there's a lot of variance in the impact for any given event. But let's start with number one. So number one is your short-term flash flooding threat. So this is going to be your threat from just individual thunderstorms or small clusters of thunderstorms that have a quick burst of anywhere from 30 minutes to maybe 90 minutes of heavy rainfall, and then either they fade away or they move to different locations. And so these kind of storms typically don't really produce a riverine response, but they can produce a flash flooding response, especially given where they fall, especially if they're falling over steeper terrain or in a location that's received a lot of antecedent moisture. And the other thing to know about these is that they're extremely common, and so they probably represent 80 or 90% of all of our events that we look out for in the flood threat bulletin. The second type of event is snowmelt flooding. And I think this one's fairly intuitive. So it happens pretty much every single year, depending on where the snowpack is the highest, as well as what is going on with temperature. So essentially, as soon as you get that springtime, late springtime and early summer heat, where your nighttime temperatures in the higher terrain aren't really falling below zero, that's when you really start to drive that snowmelt. And the typical impact, fortunately, is mostly low in terms of it's a low threat to maybe moderate threat at times, but unless we have rainfall coinciding with the snowmelt, we typically don't see very serious situations from this. And again, that's very common during the May and June months, sometimes even April, like this year in the Southwest. So the next event is probably it's actually by far the most severe event that we know historically and what people typically remember, but it's extremely uncommon, which makes it really tough because we have such a limited sample from which to learn. And so we're just constantly trying to understand these events better. And this is your medium and long-term flash flooding and cascading into riverine flooding. So think about most recently the Boulder 2013 flood. So that one really, I mean, that was unprecedented in the sense of the duration. It was 3 to 5 days, even longer perhaps, in localized areas. And this is where you have not necessarily very heavy rainfall, but you just have continuous rainfall, moderate to heavy, that generally exceeds 90 minutes. And so at that point, you start impacting riverine conditions. And so this event is driven not just by your local moisture and instability, which drives your individual thunderstorms events, but typically here you start seeing large-scale moisture transport from, let's say, the Gulf of Mexico, or it could be a monsoonal surge all the way from the central Mexican plateau. So very large-scale plumes of moisture, kind of like atmospheric rivers is how they describe them in California. It's not unlike that, except they're much less common here. And so it happens, we said maybe a few times per year, but some years it seems like we don't really even see this kind of event. But when we do, it's very memorable, obviously. So the impact is typically high or even high impact, and we'll discuss our categories in a little bit here. And finally, the last event is kind of an interesting one, because when I first started forecasting, I read a lot about it. It's the rain on snow event. So essentially what happens when you have snow melt, maybe not quite in its peak, but about to start or already just started, and then you have a rainfall event that occurs on top of it. So the interesting thing here is that it's actually really hard to find these events historically. So for whatever reason, it seems like they never quite line up just right, because typically if you have a big snowpack in place, that means you had cold conditions with limited moisture. And so it really, it seems like fortunately, maybe we haven't dealt with this event, but certainly if you think about the factors that are involved with it, Colorado has them all, and so there is a potential in our climate here to have this rain on snow event where you have let's say event number 2, which is snowmelt flooding, coinciding with either event number 1 or event number 3, and so it's just something to keep in the back of your mind. So that's a summary of the types of events. And now I think it's always fun to talk about these historic events because they really are incredible in terms of just thinking about how far out of bounds some of these events were. So 1965, I think many folks are familiar with that event. And I think most people are familiar with what happened in Denver because this is what led to the building of Chatfield Reservoir. And so this is when 14 inches fell over 4 hours along the Palmer Divide, along the northern face of the Palmer Divide. And Plum Creek went from 150 CFS to over 100,000 CFS in a span of 3 hours and just caused a massive wall of water to go downstream. The interesting thing with this is that this wasn't just actually a localized event, because you'll see the next event here, June 17th through the 19th of 1965, the Arkansas River, which is quite a bit further southeast, it was impacted by widespread long-term rainfall, 5 to 15 inches that fell over about a 5 to 7 day span. And we saw just continuous, really high base flow and a couple of peaks in the Arkansas River of 30 to 50,000 CFS. And the really incredible part was that this covered a span from Pueblo all the way through the Kansas border. So prolonged high intensity event here. In terms of the shorter duration, but just kind of absolute freak events, Big Thompson is probably the runaway winner with that. And so there you have 12 to 14 inches falling mostly in that 4 to 6 hour duration. And even if you drill down beyond that, it was really just short-term bursts of incredible amounts of rainfall, including this observation of potentially seven inches falling in 70 minutes, which is just incredible. And so obviously there was a huge spike on the Big Thompson with that event. So an interesting event that's a little bit out of flavor compared to the flash flooding ones, the first 3 that are flash flooding driven, is water years 1983 and 1984, which was following a big El Nino event out in the Pacific Ocean. The Colorado River saw 2 consecutive just massive snowpacks, and there were peak flows both of those years above 60,000 CFS. And I think this was at the Utah state line. So that's just incredible. And just for reference, obviously we've had a string of pretty bad luck years recently, but I think last year's peak was something like 8 to 10,000 CFS. So massive, massive flows on the Colorado River, driven essentially entirely from snowpack alone. So the next event is similar to the Big Thompson, just a little bit lower in magnitude, but it's the July 28th, 1997 flash flooding event near Fort Collins. So this one had 10 inches over 5 to 6 hours. And one thing that's interesting to note about this one is that it actually inspired the creation of CoCoRaHS, which I'm a dedicated observer for CoCoRaHS. And if you haven't heard of CoCoRaHS, I highly recommend that you check it out. But it's essentially a volunteer-based program where you get these official rain buckets and you're able to measure the rainfall. And the CoCoRaHS is a huge tool that we use for our verification. So interesting to note that. And then finally, I think the Boulder 2013 event everybody's fairly familiar with, and there was a peak of about 17 inches falling in 3 to 5 days, which just kept riverine conditions extremely high across many basins in the Front Range. So yeah, in short, Colorado has, given our semi-arid climate, we have an incredible history of flooding events, which has inspired the Flood Threat Bulletin program. So let's